Today let's work on the concept of lines. Lines in Rn. So all of us know how to define a line in R, right? It's very simple. In R2, it's very simple. Now, if we try to visualize lines in spaces higher dimensions, so like R3, R4, Rn, what a line would be there? What we can do is we can use points in Rn and vectors to define such lines, to find the equation of such lines. Now, how? So suppose what I'm trying to tell you is, suppose there's this line L in some space, okay, in Rn, say, this is line L. So how I can define this line L is with the help of, say, this point P, and along with this vector in the direction D. So vectors have this direction, right? Sense of direction. So with the help of these two things, I would be able to define a line like this. In fact, suppose line, I want to define, let's take another point Q. So if we observe PQ, the length of PQ, or PQ, the line, now you can see that it's in the same direction as D, right? D, the vector, direction vector, what we call. PQ is in the same direction. You can say that PQ is in some way parallel to D. If we observe the vector PQ, we can say the vector PQ is parallel to D. What actually it would mean, in other words, we can say that is, there exists some real number, say T, such that I can say that the vector PQ is actually equal to T times D. Now PQ, this point Q is on the line L. It could be anywhere. It could be here, here, here. So depending on T, the length could keep on changing. What we can say is that it's the position vector of the point P, or in other words, basically, if this is, say, the origin 0, then this is your, say, lowercase p, that is the position vector. Okay, this is P. And then T could be equal to 1, could be 2, and so on and so forth. With different T's, we will be on this line only, and so on and so forth. Okay. Now, which basically tells us one important thing here. We can say that suppose Q is the position vector of capital Q, the point Q, then can you see something? The length, or the vector PQ, we can write that PQ vector is nothing but Q minus P, difference between the two, right? In other words, what I can say that, I know that PQ is equal to T times D. So Q minus P is equal to T times D. And that gives us Q is equal to P plus T times D. This is the vector equation of the line L. With D being the direction vector. This is a very important concept in linear algebra to understand lines and planes, because when it comes out to be, at the level where we are trying to find solutions to different equations, set of equations, with respect to whatever the questions are. Sometimes we would see plane, we would see equation of lines. You need to understand what is an equation of a vector equation of a line, what is a vector equation of planes. I'll come to that later. So formally speaking, let P be a vector and D a non-zero vector. So formally speaking, let P be a vector and D a non-zero vector. Then Q equals to P plus T times D is the vector equation of a straight line L. More specifically, T belongs to R. T could be any real number. Q, let's apply this and understand. So let's take P as 2, 0, 3. P, the vector, the point is 2, 0, 3. And direction D, direction vector is 1, 2, 1. Transpose, that's how we write it. So if we want to find the vector equation find a vector equation for the line that contains, find a vector equation for the line that contains the point P as given to us and has the direction vector D. How would you do that? Well, what will be your position vector? If the point is 2, 0, 3, the position vector P would be taken as the transpose of 2, 0, 3, and Q for the equation of the vector equation of the line is Q equals to P plus T times D, that is 2, 0, 3 plus T times 1, 2, 1. With different T's, you can find the point Q on this line. So the line would contain all the T's, where T is any real number, and this will be your vector equation. Now suppose within this concept, if I ask you another question, if I ask you the equation of line, vector equation of line through 2 points P and say another point R. So say P is 1, 2, 0, 1 and R is 2, minus 4, 6, 3, both in R4. Can we find equation, vector equation for the line through these 2 points? Well, yes, we can. We are not given the direction vector here, but we can take PR vector, PR or the length PR as the direction, as D. So what we can do is, we can look at R minus P. So that would give us 2 minus 1, 1, minus 4 minus 2, minus 6, 6 minus 0, 6, 3 minus 1, 2. The transpose of this as D, the direction. Okay. So if you've understood the figure, the line that the way I've taught you, then you can probably grasp this easily. So if I take this as my direction, then the equation Q equals to P plus T times D could be taken as Q is equal to P 1, 2, 0, 1 plus t times 1 minus 6, 6, 2. In other words, you can also see that this expression could be written as, if I extend it, can you see what I can write it down as? I can write it down as x1, x2, so on and so forth. Had it been Rn, so I could have written it x1, x2 till xn. And this is equal to p1, p2, which corresponds to the point P, the position vector, t times corresponding to the direction vector, d1, d2, so on and so forth. This is called the component form. Of the vector equation. Now, because you do have a component form of vector equation, that is why you can even change parameters. So, for example, if I come back to this example that we took, okay. Now here we can say that x, y, z, that is equal to 203 plus t times 121. Suppose I want to change the parameter to say, instead of t, I want it to be 3 times, say, some s, or instead of t, I want it to be 1 minus, say, r. So I can do that. Because what I'm just going to do is instead of this, I'm going to put 3s, and your x, y, z would turn into 203 plus, it's 3s. So I can say s, and I can just multiply 3 inside here. So 363 multiplied by s. Similarly, you can do it with some other parameter. So you can do that parametric shift also, because you have that component. You can write it down as a component what it is. So you can always do that. Okay. So what we have learned today is what is an equation of a line in Rn. Similarly, we will be talking about in the next video about the planes, equation of planes in Rn. Once we understand this base, we can move on to some other details in linear algebra. Thank you very much.